Okay, so the next type of word problems we're going to look at is solving uniform motion applications. So these types of applications involve distance, rate, and time variables. And so this is the relation between distance, rate, and time. So distance is equal to rate times time. Distance can be in inches, feet, yards, miles, nanometers, meters, so on. Rate can be distance per unit time, such as miles per hour, meters per second, so on. And time can be like picoseconds, milliseconds, seconds, minutes, hours, years, and so forth. So, for example, if we kind of do some unit cancellation, showing, distance is equal to rate times time. Here we've got a rate of miles per hour, and time is also measured in hours. And you can see that hours cancels with hours. The units of hours cancel, leaving you with just miles, which once you do this multiplication gives you your distance, which is in miles. So again, this is a handy way where cancellation of units is really helpful in helping you to determine whether the solution that you're calculating is correct. This type of thing will also help you a lot in other science classes like chemistry and physics and biology when you have to do certain calculations. Okay, so let's apply this general idea, although this looks very much like the previous ideas that we've done with this example here. So in this example, it's from Riverside Park to the beach. So Wayne and Dennis like to ride the bike path from Riverside Park to the beach. Dennis's speed is 7 miles per hour faster than Wayne's speed. It takes Wayne 2 hours to ride to the beach, while it takes Dennis 1.5 hours for the ride. Find the speed of both bikers. All right, so let's maybe draw a picture of this to see what we've got. So we may not remember just the particulars, but let's try and draw a picture here to help us out. So here's going to be our starting point, and this is Riverside Park. Then over here is going to be the beach. All right, and we have two people, Dennis and Wayne. So we've got Dennis and Wayne. And so Riverside Park is like their starting line, and the beach is their finish line. All right, and so, Dennis starts at Riverside Park and rides his bike all the way to the beach. And Wayne gets on his bike at Riverside Park and he rides it all the way to the beach. All right, so let's see what we've got here. So we got Wayne and Dennis like to ride the bike path from Riverside Park to the beach. Okay, so we've already taken care of that. Dennis's speed is 7 miles per hour faster than Wayne's. Okay, it takes Wayne 2 hours to ride to the beach. Okay, let's look at this one. So it takes Wayne 2 hours to ride to the beach. So this is going to be time for Wayne, and that takes him 2 hours. So if we come down to our picture for Wayne, the amount of time it takes him is 2 hours. All right, while it takes Dennis 1.5 hours for the ride. All right, so the time for Dennis is 1.5. So we'll put the time for Dennis is 1.5. All right, let's see what else that we've got. All right. So Wayne and Dennis like to ride the bike path. I'm going to see Dennis's speed. Okay, so Dennis's speed. Okay, so that's going to be the rate of Dennis is, so that's equals to 7 miles per hour faster. So that's another way of saying plus 7 than Wayne's speed. So Wayne's speed is going to be rate of Wayne. So Dennis's speed is Wayne's rate plus 7. All right, so Dennis's rate is equal to Wayne's rate plus 7. And we've pretty much covered all the information that we were given. So all we have left here is Wayne's speed or Wayne's rate. Okay, now there's one particular aspect of the relationship between Dennis and Wayne that's special here. Do you see it? So notice that the path traveled by both Dennis and Wayne is the same distance. So the distance that Dennis travels is the same distance that Wayne travels, right? They're both traveling from Riverside Park to the beach. So we've got Dennis's distance and we've got Wayne's distance, and those two distances are the same. So that key observation is something that we're going to be using shortly. All right, so let's set up our table. So, before we had type, I'll just go ahead and put type again, just to stay uniform with everything else. Okay, so type, and then we've got rate, which is in miles per hour. And then we've got time, which is in hours. And then we have distance, which is, I think, miles. Right. It just says, yeah, we don't. So I think it's going to be miles per hour. I'm sorry, distance. Gosh, sorry, is just going to be in miles. Okay. And the type is we've got Dennis, we've got Wayne. All right. So for Dennis's rate, we have this relationship here. So Dennis's rate, let me use a different color. That helps it stand out here in the middle. So Dennis's rate is, I don't know why I'm making so many mistakes here. Come on. Okay. Wayne's weight plus 7. The time for Dennis is 1.5. And so the distance is going to be rate times time, and that's equal to distance. So that's going to be 1.5 times the rate of Wayne plus 7. And that's equal to Dennis's distance. Okay, so Wayne's rate, we don't know what that is. It's just R sub W. The amount of time it takes Wayne is 2 hours. And so the distance will be 2 times the rate of Wayne. So that'll be the distance that Wayne travels. Now, remember earlier up here, I made this observation about the distances being equal. Well, that means we're going to set these two equal to each other as soon as my PC cools down. All right. So we're going to have Dennis's distance equal to Wayne's distance. All right, that's kind of strange why that happened. Where's that? All right, let's do this again. So we've got Dennis's distance equal to Wayne's distance. And we know that Dennis's distance is 1.5 times the rate of Wayne plus 7. And that's going to be equal to Wayne's distance, which is 2 times the rate of Wayne. So here we have to do the distributive property. So we've got 1.5 rate of Wayne plus 1.5 times 7. It's going to be 10.5. And this is 2 RW. So we need to, let's subtract 1.5, the rate of Wayne, from both sides, because these are like terms. So that'll add up to 0. So we've got 10.5 is equal to 0.5 times the rate of Wayne. Divide both sides by 0.5. And the rate of Wayne is equal to 10.5 divided by 0.5, which is 21 miles per hour. Okay. So what we still need to find is the rate of Dennis. And from up above here, we can see that rate of Dennis is equal to the rate of Wayne plus 7. Well, we just found the rate of Wayne. That was 21. And so 21 plus 7 is Dennis's speed of 28 miles per hour. So find the speed of both bikers. So the speeds of, let's see here, let's do the speeds of Dennis and Wayne were, so Dennis were 28 miles per hour and 21 miles per hour. Respectively. And that's our answer. Let me know if you have any questions.